Good afternoon, everyone, and welcome to the first of the 13 webinars that are part of the 2020 EMOS webinars program. My name is Caterina Giusti. I'm Professor of Statistics at the University of Pisa in Italy, and today I will act as the webinar facilitator. As this is a live event, I would like to specify that today I'm connected from my house, as all the other members of the EMOS staff of the University of Pisa, as we fully respect the direction of the Italian government and the University of Pisa to prevent the spread of the coronavirus. So going back to our webinar, let me first explain for any newcomers that EMOS stands for the European Master in Official Statistics, a joint project of university and data producers in the EU member states, EFEA, and EU candidate countries. If your university is interested in applying for the EMOS label, please consider that a permanently open call for university is available on the EMOS dedicated page on the Eurostat website. For staying in contact with the EMOS news and community, please follow the EMOS on Twitter. The EMOS account is @EU_EMOS. Now, before I give the floor to our speaker, let me briefly explain how we run the webinar today. As a participant, you can watch and listen to the session. To interact with the presenter, you can use the chat represented by the comic symbol. We encourage you to prepare your questions and post them during the presentation or the question breaks. We will have some question breaks and a final discussion to reply to the questions. Should you have any technical problem, please try restart your Skype for Business or the computer or device that you are using. For more specific technical questions, you can use the chat and you will receive a personal reply. In any case, please consider that the slides of the presentation are already available on the EMOS 2020 events website. Today, I have the great pleasure to host Dr. Jens Mehrhoff from Deutsche Bundesbank. Dr. Jens Mehrhoff is advisor in the Office of the Director General Statistics at Deutsche Bundesbank, where he is in charge of setting up the Sustainable Financial Data Hub. Prior to his current role, Jens was head of the section for business cycle, price, and property market statistics for many years, and recently on secondment to the European Commission. Jens is a member of the task team on scanner data, of the UN Global Working Group of Big Data, the ONS Technical Advisory Panel on Consumer Prices, and the Steering Committee on the UN Hot-One Group on Prices Indexes. He is also served as representative of the European System of Central Banks and on the ESS EMOS board. Okay, so today he will present about, as you can see, consumer price indices from traditional to new data sources and techniques. So Jens, thank you. The floor now is yours until our first question break.
Grazie mille, Caterina. Andrea tutto bene. And good afternoon to all of you out there in your living rooms. As you can see, I'm still in my office, but this will be the last day I will be going to the office and then also do teleworking. As you heard, I will be talking about consumer price indices today, from traditional to new data sources and techniques. And you certainly have already seen on the website the details of the webinar. Just the two main questions we will be addressing in the next hour or so is, what are the conceptual and practical measurement problems in measuring inflation in the digital economy? And secondly, what are the methodological issues and practical experiences with the use of big data for compiling consumer price indices? On the matter of big data, I would also like to recommend the first talk in this year's EMOS webinar series by Albrecht Wirtmann on trusted smart statistics, where he also touched on this issue. Before we go into these more detailed areas, we will also look at the European Harmonized Index of Consumer Prices as an introduction to know what we will be talking about in more detail. I will not be talking about Corona today, which might have been much more topical, but just saying there's also an issue with the virus and price measurement. That is, how should we deal with the cancellations we now see with flights and package holidays? But as I said, that's not the topic of today. If you would like to get into further details of the issues around price measurement, here are some references where you can look into more detail into digitalization and new data sources. So let's get started. The European Harmonized Index of Consumer Prices. So this will be about inflation measurement. So my first question for you, and type it in the chat, is what is the today's released inflation rate in the euro area? Don't look it up, just guess what it is. Write it in the chat. All right, here we go. So the isHICPE for short is a specific measure that is developed in the EU for indices that can be directly compared and aggregated across countries. What we do on the central banking side, it is used in the monetary policy strategy, particularly in quantifying the price stability criterion, where price stability is defined as a year-on-year increase in the isHICPE for the euro area of below 2%. So it's crucial to understand here that the definition of price stability means rates, inflation rates, between 0% and 2%. However, the Governing Council has clarified that in the pursuit of price stability, it aims to maintain inflation rate below but close to 2% over the medium term. So that, in contrast to the definition, is a more specific monetary policy aim, but that does not mean that the EU system has an inflation target of 2%, which is not the case. Further, it is used for assessing the price stability criterion, which is a convergence criterion for member states who want to join the euro area. Over and above of this specific monetary policy uses, of course, the isHICPE can and is used as an economic indicator for analyzing the state of the economy and for indexing, for example, contracts and wages. So a bit more technical details. What is the isHICPE conceptually? Conceptually, it is called a LSPI type index. You might have come across a LSPI index during your studies. LSPI type means we are doing a bit differently. So what we do, we still look at the price changes of products over time. So PI denotes prices of the ICE product, and we have two periods we take into consideration here in the formula. So there is in the denominator the price reference period denoted as 0T. That is December of the previous year. So throughout a given year, we compare the prices of the current period, the comparison period, MT, to the prices of the previous December. That means we are eventually ending up with a series of 13 months where we always compare the current months to the previous December. We then apply annual weights to come up with the overall LSPI type price index. These weights are derived in general from national accounts, but also from other secondary statistics. So that means now we do have these 13 indices, but in reality, we cannot do this calculation for each and every product out there. So in reality, we have to look at what is called elementary aggregates. The problem is, in reality, in practice, we have to construct the isHICPE in two stages. There's a first stage of aggregation where we only have prices but not the associated weights. And there's a second stage of aggregation where we indeed do have these weights for higher level aggregation. For the rest of this talk, particularly when we talk about digitalization and big data, we will focus on this lower level, so the elementary aggregates. The problem is we have to do something differently here since we do not have weights, and we will apply elementary aggregate indices, here denoted as PI, and then at this level we will apply the weights. For this PI, there are usually two formulas used in the isHICPE and also national consumer price indices anywhere else in the world. So the first index that we normally come across is a Duteau index. That is the ratio of arithmetic mean prices. So as you can see in the numerator, we take just the arithmetic mean of prices today and divide them in the denominator with the average prices in the price reference period, December of the previous year. We can do the same calculation also in a geometric manner, which will lead to the Jevons index. So that's a ratio of geometric mean prices, or because of this particular property, also the geometric mean of price relatives. So empirically, the Duteau and Jevons will be close to each other in most situations, not necessarily in all. But these are the formulas that are actually used in price index calculation at the truly item level, at the lowest level of index calculation. And in digitalization, we will see the issue with which prices to plug in here. And with big data, we will see a completely different approach to this elementary indices. The problem with digitalization will be what happens if we cannot compare the same products over time. And similar problem with big data, where we will just also have many more observations than we do in traditional price collection. So the first stage of aggregation, Duteau or Jevons. The second stage of aggregation, l'SPI type. But as you have seen, we end up with an index which is just for 13 months. So this price reference period is changed every year, which means we have this short-term index of 13 months, but we also want to make the longer-term comparisons. These longer-term comparisons are achieved by what is known as chain linking. So what we do in the isHICPE, we chain link every year on the December of the previous year. So in the longer term, we are actually chain linking December with December with December with December. Just at the very end, we are linking with the current months. So maybe this is better understood in a more graphical manner. As you can see here, in the top panel, you see the short-term l'SPI indices, where I just simulated a sinus curve. And you see that these always start at 100 in December and then end up at something else in the next December. Then a new series starts at 100, which goes until the next December. But in the shaded areas, you can see that there's an overlap between the old series and the new series. And this overlap we do use for the chain linking, just applying the rule of 3. So we shift the level of the new series to the old, and shift it again and shift it again to construct the long-term index. So this was a very rough and quick and dirty introduction into the isHICPE. But the point is, what you should take from this part, which is not the focus of the talk, is how we do measure consumer prices in Europe. So we do have a measure which is tailor-made for monetary policy. We do have to understand that the construction is actually done in 2 stages using elementary aggregates, and we will focus on these elementary aggregates in what follows. And if you want to do a long-term comparison, we do this annual chain linking via December of the previous year. In the appendix to these slides, you will also find a numerical example, which is fully worked in Excel file. There is a hyperlink in the slides. You can just click on it and you can download the Excel file from the Eurostat website. So if you have any questions on this particular part, I would be happy to answer them now.
Yes, please. If you have questions, you can use the chat. Of course, this is just the first part. Then we will have another question break in another 12 slides. Okay, so maybe this is...
I can't see any, so...
Yeah, no. For the moment, no questions. This was, I think, the introduction.
Yeah, it was the introduction indeed.
Yeah.
As I said, this is not the focus of the talk. I just want to give you a bit of a background on the isHICPE, because this is a bit special in the family of international consumer price indices, because it has a specific target, which is monetary policy strategy, while other indices out there in the world have different specific targets. So once we have covered this now, and I can't see any further questions arriving now, let's come to the first big topic of this talk. That is digitalization and the impact on inflation measurement. What does it mean? Well, I forgot one thing to mention here. So because nobody said something, the actual inflation rate currently is at 1.2%. So we are in the domain of price stability right now. Digitalization. Right. So we do have some long-standing challenges in consumer price indices with a changing economy. So you might have heard about the sharing economy, Airbnb and Uber. And the question that revolves around that is capturing quality change. This is not a new problem, but it has now been amplified by digitalization. So the problems I will be presenting now are by no means new. We just have them to a much bigger degree than we had them in the past in consumer price indices. So what we now see in the economic debate is whether there is an issue with CPI measurement and vis-a-vis growth measurement. So I do assume there will also be a webinar on national accounts. They will certainly also talk about digitalization, because every measurement error that is done on the price index side will also lead to measurement errors on the real GDP side, so on the output side. Hence, there is this link between prices and national accounts. However, quite generally, it is said that it's conceptually relevant to understand the impact of digitalization on the consumer inflation as measured by the CPI. In particular, there are three issues which are highlighted in this debate, and these largely revolve around incomplete adjustment for quality change. So what we'll be talking about in the next couple of minutes is all about quality change, and we will have an example on that in a second. So the first issue is, how shall we treat new varieties of existing digital products? So a new computer arrives in the market with new functionalities, a bigger hard disk, etc., etc. So how shall that be accounted in consumer price indices? The second question is the treatment of new digital products that replace existing non-digital products. So in the past, you might have bought a CD or a Blu-ray, but now you can get the same service from streaming from the internet. So now there is a digital product, the streaming, which replaces a non-digital product, the CD or the Blu-ray disc. How shall that be accounted for in consumer price indices? And the third question, and this list is certainly not exclusive, is how shall we go about the improved variety selection of digital and non-digital products? So it's quite common nowadays to shop clothing, books, and many more things online. Well, in the past, you had to go to the local brick and mortar store to shop these goods. Now you can do it online, and you might most certainly have a broader choice of products available online than in your local store. How shall that be reflected in consumer price indices? I will focus on the first point here, that is the treatment of new and often improved varieties of existing digital products. There has been a study by Weinstoff and Schreier, which is also linked in the references, which look at the upper bounds impacts on the price index for household consumption in OECD countries. So they try to look at what is the maximum possible impact of digitalization on the mismeasurement of consumer prices. So they did kind of a simulation study based on assumptions, and the results were as follows. So for the first point, which we'll look into a second in more detail, they arrived at the annual rate is overstated by 0.41 percentage point, which is driven mainly by a 0.2 percentage point overestimation for telecommunication services. So using the internet and your mobile phone apparently has become cheaper and more so than it is reflected in consumer price indices today. Same story for the second point, the digital replacements, where they arrive at a mismeasurement of 0.11 percentage point, and for the improved variety selection, another 0.05 percentage point. So combining all these three effects together, they arrive at an upper bound of 0.57 percentage point that inflation is measured, mismeasured due to the effects of digitalization. As I said, this is a simulation study and it is the upper bound in their assumptions. So this is not necessarily saying that inflation indeed is mismeasured to this degree. All what we can say with certainty is that the effects of digitalization are not yet fully captured in consumer price indices, which, by the way, does not only apply to Europe, but also to other countries elsewhere. So I wanted to go now into a more detailed example with you, and to that end, I will for a second skip 2 slides and then come back to them. But I have a question on this particular chart. So we are now on page 18 of the presentation, where I have plotted for you the stylized price paths of different iPhone models. And as the slide title says, do higher prices reflect quality growth or inflation? So what you can see at the bottom of the chart is the iPhone 8 and the iPhone 8 Plus, followed then by the iPhone XR, and last but not least, the iPhone 11 Pro and Pro Max. So my question now for you in the chat is the difference in prices we do see between these different iPhone models, these newly introduced varieties of the iPhone. Do you think that these price level differences are due to a different quality? Then please type a Q. Or do you think this is genuine price change and hence is inflation? Then please type an I into the chat and we see how you think about this. So this is a real world situation. I used list prices by Apple and then made a stylized price part than the highly fluctuating thing you would have seen in real time. So, but interestingly, it's already coming. A lot say inflation already. We talk about that now in more detail. So back to slide 16, where we now discuss what's happening here. We now have different options, obviously. So the iPhone 8, just going back to slide 18 again, the iPhone 8 and the 8 Plus were available from September 17 throughout to the last month, February 2020. The iPhone XR only arrived in the market, at least in Europe, in October 18, while the iPhone 11 just came in September 19. So obviously, if you want to have a time series that goes from September 17 to February 20, the only single model you could use is the iPhone 8. So that's one option, quite obviously. However, what we normally do see, and this is not a general rule, this is a stylized facts I'm giving you now. So if you only look at the iPhone 8, that is what we would call the matched models approach. So we look at the prices of the continuing products. In general, this leads to an overestimation of inflation for digital products. This might not necessarily apply one-to-one to other product groups, but what we normally do recommend is to refresh your sample. So sample refreshment means you bring in the new products and product varieties that have appeared in the market since you last refreshed the sample, which means a newly selected sample is linked in and the old one is linked out. And as always, there is an overlap between the new and the old sample, which is either December, which is the month where we do the linking, the chain linking for the overall isHICPE, or you could, at least in theory, do this immediately once a new product or variety comes into the market. So there are a couple of things now going on. First, when we do have significant quality improvement, and most of you did not consider this a quality improvement, then if we do not adjust for that improvement, necessarily we will overstate the product's price change. If we assume the price level changes for the different varieties are pure price changes, then we show too much price change if indeed there is quality improvement, at least partially. Secondly, and we will see that in this individual example in a second again, the longer we wait with the introduction of the new products, the bigger might be the problem in digital products, since you miss the price declines of digital products, particularly in early stages of their life. A third issue here is that the quality increases might even be bigger than the price differences. So indeed, if you do run a direct or explicit quality adjustment, you might adjust for more than just the sheer price level difference. And we will see that in a second as well. So with all these 3 points, I've now been talking about that we overestimate the price change, hence underestimate the quality change. But there's also a discussion, much less so, but this should not be overlooked by all means, that we might also overstate the quality change and hence understate price change. The example here is that we do not explicitly capture the quality decline if we need to purchase a new model of mobile phones or computers in the absence of backwards compatibility of new software with older hardware. So you might need to buy a new computer just to run the latest software on it, but you might have been perfectly fine with the old hardware and the old software. However, if the support and maintenance is stopped for this old software, you do need the new hardware and the new software. So you have to spend money just to continue working without this new hardware with a new better quality giving you extra utility. So this should not be overlooked, but in general, again, not in all cases, in general, this overlooked quality change for digital products most likely is an insufficient capture of the quality improvement. But just repeating that point because it's quite particular, the quality change might go in either direction. So it's not necessarily upwards, it might also be downwards. The problem is there is lots of perceptions and opinions out there. And so if we now come back to our example, I will now show you how this translates into different price indices you can calculate for these 3 iPhone models. So now I do restrict myself to the iPhone 8, the iPhone XR, and the iPhone 11. And I calculate a price index based on these 3 iPhone models. And I do not calculate just one index because, as I said, the question now, is it inflation or is it quality growth? Most of you have set inflation, some of you had set quality growth and inflation, and depending on your personal perception, if you were sitting in the National Statistical Office and doing the actual calculation, you get something like this. So let me talk you through this chart. So quite obviously, when there is just one model available, the iPhone 8, that is until September 18, then you can, October 18, then you can just do one index, and that's for the iPhone 8. So in the first months, we just see the development of the iPhone 8. But then we see it's either going up or down. Let's start from the top. So the top line is if you assumed that the whole difference we see between the iPhone 8, the iPhone XR, and the iPhone 11 is pure price change. They are of exactly the same quality. If you do so, then you're linking the, in the meantime, lower price of the iPhone 8 to the higher price level of the iPhone 10, and later again to the higher price level of the iPhone 11. And here I assume we do this kind of linking in December, and you end up with a price index which was 100 in December 17, which is in its final month, February 20, around 120. So you would assume a 20% price increase in iPhone prices if you follow this approach. Let's take the next approach. You assume that the difference is pure quality change. So all the price level difference you observed in the chart before is perfectly due to quality. And again, we do the linking in December. What you then see is that this line is a bit below the memo item, which is the iPhone 8 only, which is due to the fact that we now follow only the price level changes. So if you assume pure price change, we follow the price levels. If we assume pure quality change, we only follow the price changes. And these are going down, 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 and down, but never up. We could have done so, the next darker line, linking it immediately, and we see immediately that this line goes further down, and this was the second point I discussed. A late introduction might introduce more bias if you assume this to be bias. But there is a fifth line which goes down all the way, and that is a direct quality adjustment. So if you now look at the technical specifications of the different iPhones, so whether it's 64 gigabytes of RAM or 128, how many megapixels a camera has, whether it has 1, 2, or 3 cameras, and so forth, and so forth, you can run a regression model and come up with a price for this new iPhone in an earlier period. If you follow this approach, you might have gone down all the way to a price decline of 40%. So what we do see here now, you have basically the choice between a price increase of 20 and a price decline of 40%. What is correct? I don't know. As I said, quality adjustment is as much an art as a science and a matter of debate and personal perception. So this is the implied quality you would assume following either of these approaches. So the price changes we saw on the earlier slides can be translated into what it means implicitly for the quality you assume behind that. And you might assume that the quality of the, in the highest case, of the iPhone 11 is twice as high as that of the iPhone 8, or just 40 or 60% higher. And as I said, there are lots of opinions out there, and I'm afraid there is no correct answer to this particular question. So summarizing this little example, you have the choice between an average annual rate for the pure price change scenario of 8% and the direct quality adjustment of -20. If you just look at the iPhone 8 all the way through, you would have ended up with a -10% average annual rate. Just for comparison, Reinsdorf and Schreier in their study assumed a 5 percentage point overestimation. So the range might be even bigger, but I admit this is a made-up example and quite extreme. Talking about made-up examples, how does the HICP look like? Well, this is the data as it has been released this morning by Eurostat for the HICP for mobile telephone equipment. So this is 99% smartphones. As you can see, there is quite a difference in the developments between the member states. And for visibility, I've chosen only the 12 countries that were in the euro area in 2001, so the initial euro area countries. What the first thing that is certainly striking you is a trough you see in 2016. That is for Austria, and this was due to a massive price reduction for a very common model. So this has nothing to do with digitalization at all. So we can certainly and happily ignore this for the rest of this talk. Let's look more towards the end of this chart. So what you can see is 2015 equal 100, and Portugal ends up in February 2020 with an index of over 130. So that means for Portugal, this would be a 30% price increase. Finland, on the other end, you end up with an index of below 40, which means you have a 60% price decline. Now, again, this is a personal perception, and I don't know the truth, and I particularly don't know all the country particularities, but let's assume that a mobile phone, for simplicity, has cost 100 euros in 2015. So this same mobile phone or its successors would now cost 130 in Portugal or 40 euros in Finland. Now, mobile phones are quite a homogeneous good. So you get the same iPhone and the same Samsung all over the place. So personally, I would say that the difference we see here in the indices is a bit broad to reflect real developments in the markets. But again, the health warning, I do not know all the country particularities, nor do I know all the details about the index calculation, just a personal perception here. This is just the price changes over the same period which we looked at the iPhone, so from December 17 to February 2020. So particularly the trough in Austria is not part of this calculation. And you see that the price changes we see in Europe, in the core euro area, are anywhere between Belgium -4% and Ireland -18%. What is correct? Again, I do not know, but I do see that there's quite a variability between countries, and that is one area Eurostat is currently looking into. So quite obviously, something is not aligned here, and this is one area the colleagues in Luxembourg are currently trying to make ground on. Lastly, what we do see in this chart here is also partly due to different philosophies. So is the iPhone 8 and the iPhone 10 the same, yes or no? And if the answer is no, how different are they? And there are different answers in different member states. Which brings me to the end of this second part, where we have looked at digitalization and the measurement of inflation quite generally. So what are the issues? We looked in particular at how do we go about new varieties of digital products. We did make an example with the iPhones 8, 10R and 11, and we looked at the actual changes just released today by Eurostat for smartphones in the 12 areas of in the 12 countries of the euro area. And I'm happy to receive your questions on this part.
So if you have questions, please, you can use the chat. I'm just curious, Jens, do you think it would be feasible to try to harmonize? I mean, or you think at European level,
Yeah.
it's something that you think it should be feasible at least?
That's an excellent question, and well, there were discussions about that. So maybe a couple more words on the isHICPE calculation. So the isHICPE is calculated by each member state individually according to common rules. So there are a set of rules how the isHICPE shall be compiled, with the ultimate aim that all the differences we see in the isHICPE are national differences in price developments or weights, but not in methodology. So what Eurostat then does is to aggregate these numbers to totals for the euro area, for the European Union, and so forth. So in no area it is at least foreseen currently that we do this kind of calculation centrally. But of course you could consider this. So if we assume that, and that's a bold statement, that all of the differences we see in this chart are purely methodological, there are two approaches. One is the one that is usually chosen in other areas, and that has proven very successful, and that is most likely how the colleagues in Luxembourg will go about is, that is you sit together with the member states, everybody brings on the table how they do it nationally, and then you discuss what are the best ways to do it in a harmonized manner. The final thing that will be published then is called a recommendation by Eurostat, and member states are recommended to follow this recommendation in their compilation practices. One recommendation might be, for example, that you should not assume that all price level change we see is indeed pure price change, but you should be doing some kind of quality adjustment. That is one way how you could go about it, and most likely the European Union will go down this route, and rightly so. The other way, which is always tossed around, is you do this quality adjustment centrally. So I'm not an expert in mobile phones, but how many different models or varieties are out there which you really need to look into to get a good market coverage? Let's say it's 20 or maybe even 50. So if all member states would then collect the prices on these 20 or 50 varieties in their country, and the quality adjustment, because it's all the same technical specification, and the quality adjustment would be done centralized, then you would certainly go away with all these methodological differences. I don't see that happening. I would also not recommend this the route to be going, because the idea of the isHICPE is that member states do it nationally, and of course this is a matter for discussion currently at Eurostat and with the member states, and the final outcome will be some kind of recommendation saying how you should in general treat price changes for mobile phones and other areas. So mobile phones is just one example of digital products where one needs to look into. There is a question. What?
Yes, sorry. The question. Yeah, if they are the basket of.
Yeah, sorry.
No, please, please, Jess.
Whether the basket of goods are harmonized. Well, no. The basket of goods is country specific. What is harmonized is the classification. So it's a technical term, COICOP, the classification of individual goods for consumption purposes, which is done at the UN level. Europe has an additional layer, eCOICOP, European COICOP, 5 digits. So the lowest level, for example, in COICOP is mobile telephone equipment. So that's the lowest level that is perfectly harmonized. Below that, now member states can choose whether 90% of their citizens use the iPhone or 90% use Samsung. So this is country specific, and it must be country specific to reflect the particularities in the member states. But again, the ultimate aim of the isHICPE is that the differences we do see in the figures, in the numbers, should be only due to actual price changes and not due to differences in methodology.
Okay.
I can't see any more,
Yeah.
but we have a general discussion round at the end anyways.
So
in spite of this, I will continue with the third part. So now for something completely different, the use of big data sources for consumer price indices. So we've just seen with digitalization that the problem is a quality adjustment if we cannot make this one-to-one comparison anymore. We will now alleviate this problem with scanner and web scrape data. So this is big data in consumer price indices, and these are making more and more their way into CPIs for short internationally. So scanner and web scrape data, just saying there's another question I will answer at the end, just saying. Scanner and web scrape data give a much broader access to a much broader continuum of products. So in the old days, and that's done in numerous countries still, and will be done also for numerous products groups in the future, you do sampling. So you say, well, I want to collect prices on mobile telephone equipments, so I sample a couple of varieties in the market. So with scanner and web scrape data, in inverted commas, you get just everything. So you have much more variety in your sample, but this comes at a cost. So now you all the time get products that disappear, while at the same time new products come in. That is known as churn, and we call this a dynamic product universe. So the idea of sampling was you could follow a product over a longer period of time, while with scanner and web scrape data, it might be that one particular product is available only once and then disappears again for good. A second thing that changes here now is you do get quantities sold. So scanner data, if you go to your supermarket, it's scanned at the checkout, so the barcode is scanned. And this kind of data also give you the quantity sold. With traditional price collection, someone was going physically into the supermarket and writing the price down from the shelf. So you just get the price, but not the quantity. With scanner data, you also do get the quantity. Hence, we now are able, at this elementary level, to calculate weighted indices rather than the unweighted Dutot or Jevons. The value chain of this production process can be broken down into 3 stylized phases. The first would be collecting the data. We are not going to touch upon that. The second, processing data, and we are going to look into more detail in this in a second. And the third would be the dissemination of results. So on the processing of data, they are by and large similar, but there's still institutional arrangement which makes them differ. Generally, you can look at steps like product classification, an example yet to follow. Then you aggregate more or less homogeneous products. You filter observations which are erroneous or would some way other distort the calculation. And then you do the final calculation of the index just before disseminating it. So with classification first, we are talking of tens of thousands or even more products. This is no longer possible to classify manually, but you have to do that automatically. And that's the next point we will talk about, After we have talked about classification, we will come to the index calculation, where I will introduce what is known as a multilateral approach. So the other word, bilateral, that is the LSPI index we've seen in the introduction, which means we are comparing today with the price reference period December of the previous year. In a multilateral approach, simplified, you're comparing every period with every other period. But let's first start with the classification. So the classification might come from the data owner, at least to some extent. So supermarkets in general have their own classification in place because they also do analyze their own scanner data. The same holds true for web shops, where you most likely find the products presented in a structured way. However, we need this classification towards this official classification for price indexes, COICOP, and it might not be available at all or not be sufficiently detailed for the purpose. If that is the case, since we cannot do it anymore manually, we have to do it via supervised machine learning. For supervised machine learning, what you do need is a small labeled data set in order to train the algorithm. The information you have available to train the machine generally is the data you get from the data owner. It includes product codes. You might have heard the term EAN, European Article Number. This term as such is now outdated. The new term is GTIN, Global Trade Identification Number. You in general get a product description, a text field, and you might get other metadata such as the size. A major challenge here now is feature engineering. How do you go from this scattered information towards the classification? Example on the next slide. And in general, the problems are here that the product descriptions, the text, are not natural text. It's not like I'm speaking now. So Siri would be, or Alex, would be very good in now capturing what I'm saying. The product descriptions you get in scanner data are much shorter, so they rely on shorthands, abbreviation, some specific codes. While on the other hand, and that's very helpful, this products codes in general follow a particular structure. And here's an example for that, which I looked up from the Dominicks Finer Foods dataset. The Dominicks we will use in a second again for the index calculation as well, is a publicly available dataset. And on the link on the slide, you can actually get all the information to download and make it accessible for your own purposes. So what do we find in this data set? So one example here from the bottled juice category. You do see the picture. It's Mott's 100% original apple juice. What is in the Dominicks data set is just Mott's regular apple. What we do have on the other hand is the UPC number. That's even older than EAN. It's a universal product code. You can think of that as a GTIN, the barcode. And this has a structure. 0 is the number system digit, 14800 is the manufacturer code, 00034 is a product code, and 4 is a check digit. What we also know is the product size, 64 fluid ounces, which is about 1.9 liters. So what we actually do have available in the Dominicks dataset, it's a labeled dataset. So we do know this is bottled juice. But what we do have is the UPC number, the description, Mott's regular apple, and the product size, 64 fluid ounces. So if we had not known that this is bottled juice, what can we do? Well, you might know that 14800, the manufacturer code, is Mott's. And then you might know that Mott's is a juice producer, which is a telltale that this is juice. Then you still don't know whether it's bottled or frozen or chilled or whatever kind of juice. Then you have the product description, Mott's regular apple. Well, it has apple in it, but apple might also mean it's a fruit rather than a juice. Then another telltale is the product size, which comes in fluid ounces, which tells you it's a liquid rather than if it had been in grams or pieces, then most likely it would have been a fruit rather than a juice. Now the issue here with machine learning is to learn an algorithm using the UPC number, the product description, and the product size on a labeled data set that then gives you the answer that this indeed is bottled juice. This is a hot topic currently, and I had several discussions with colleagues at the European Central Bank, for example, about this. And machine learning is the key here in going about the product classification for our purposes. Same story for web scrape data with basically the same problems. It works very well, but it doesn't work perfectly, just saying. So this is just a flavor of what the issue with classification is. Let's now move on to the index calculation. And there are different approaches you can choose. I will talk just about one approach here, because to me it's the simplest to implement. As you can see, it's a regression framework. So in basically any software package, this is a single line of code. But there are other approaches out there. The important thing about all these multilateral approaches is that they do satisfy what is called circularity. That means if you go from period 0 to period 1, and then you go from period 1 to period 2, you get the same result as if you had gone from period 0 to period 2 directly. This is important, as we shall see in a second with a numerical example, to avoid chain drift. So the bilateral formula would not satisfy circularity, and you get very, very puzzling results if you would apply the normal chain linking framework with a bilateral formula, which is why we come up with a multilateral formula here. So the time product dummy method, TPD for short in particular, is a log linear regression framework where you regress the log of the prices, left-hand side, on a constant, dummies for time, delta t, and dummies for product, gamma I. That's it. So it's basically just dummies you plug into the regression. The trick is now, if you run this regression, and you normally do this with weighted least squares, you get estimates for the delta t's. If you take the anti-log, you exponentiate the delta t's hat, you get the product, the time product dummy index. So the delta t's give you the development over time, controlling for the differences in the products I via the gamma I, the product dummies. So the delta t's are thought to measure the pure price change going through time. And we now do an example using the Dominicks Finer Foods dataset again, which is a very granular dataset, giving you 100 million observations of several thousand products in numerous categories. And the particular thing about the Dominicks dataset is that it also has a dynamic universe due to new and disappear products, the churn. So all the problems that follow from this dynamic universe can be seen from the Dominicks dataset. Although it's rather old, it still does a trick in explaining all the caveats and the methodologies around with scanner data. We do this now at a monthly frequency, not the weekly frequency in the data. And the first thing I would like to show to you is the availability of item codes over time. So there are 440 different bottled juices in the Dominicks dataset. And as you can see, some are available for quite some time, others are not. Some disappear, others are new. And those that are new might still disappear. And those that are available might be unavailable for some periods of time. So we do not have everything available in every single period. That would be the normal approach in price indexes. We have everything for every single period. Now we don't. And there we need to do something about it. And this is the multilateral approaches. So on average, every product is available 37 months out of 91. But that does include products that are available in all 91 months and products that are available only in a single month. So on average, 37 months. If we now do the calculation with the time product dummy, these are the results. So you do see the red line, weighted TPD, time product dummy. That is our reference. This is the exponentials of the delta hat t if we run the calculation with weighted least squares. I also, for comparison, plotted the same series if we do unweighted least squares. And I also added a memo item, the old CPIU. So this is American data, quite obviously. The CPI-U is the American Consumer Price Index. And as you can see, the lines are basically in sync. It's just using different data sources for the calculation. The old CPI-U was based on classical sampling. The weighted and the unweighted time product dummy are based on the scanner data in the Dominicks finite foods data set. In the bottom panel, you can see the share of products that are sold on a promotion. And what you can see from this chart is that the troughs, particularly in the weighted time product dummy, are correlated with sale periods. So whenever there's a sale period, people tend to buy more bottled juice at lower prices, and this translates into the troughs of the weighted time product dummy. We see less so in the unweighted time product dummy because the higher expenditures are not reflected in the unweighted, and we don't see anything at all in the old price series because this was not respected at all in the classical sampling. So we just discussed this, and now back to the chain drift which I mentioned before. The weighted time product dummy ends up at 124.9. If we had done a monthly chain linkless pairs, we would have ended up at more than 1,600 of the index. So this is a 16-fold increase of prices in bottled juice over just 7 years. This is just ridiculous. And this is the problem with bilateral indices. And if you apply monthly chain linking, you get severe drift. This might be upwards or downwards. In the example of the Las pairs, it's upwards. But this means we must not use our standard Las pair approach for scanner data. We must do something different, which in this case is the weighted time product dummy, but there are also other approaches out there. As I already said, the troughs are highly correlated to sale periods. So the question now is, how much more information do we have in the price indices based on scanner or web scrape data compared to the traditional methods? So in this respect, volatility and bias, and these are the last two things I would like to talk about today, are further issues in this field. Volatility, and let me be clear on that, the troughs due to sales period are not volatility. I just mean all these small going up and downs of the index formula without any real economic meaning, while the sale period has a straightforward economic meaning. But even if you account for the sale periods, what you do see, and by seeing, I mean literally seeing in a chart, that these new data sources tend to produce more volatile indices than we have from traditional approaches. So there is little to no noise in the traditional approaches, while we see quite some noise in the new approaches. So volatility is something that needs to be considered when we do our price indices on big data. On the issue of big data, and that is my final slide to wrap up, bias. I've heard quite often that we now have the population of observations. Well, unfortunately, that is not true. You get a really big sample, but it's biased because it's non-probabilistic. You just get what you get, not the population. So there are transactions that should be in the scope of the index, but are not recorded electronically, that are recorded electronically, but are not available to the statistical office, that you delete in the filtering step, that cannot be matched or linked, and so forth. The problem is not more data are better, better data are better. Certainly scanner and web scrape data are a leap in index production, but we must be aware about volatility and bias. Also, the problem is you can be very, very precise with 1 million observations, but you might be precisely off the target, so have limited accuracy. The danger here is in blindly trusting that more data are necessarily better and must give better answers, because you do not get all transactions. You just get what you get, and you might not even know which transactions you are missing. So what we do need indeed is a combination of the new sources with the more traditional sources to reduce this coverage bias, as it's called in statistics. Last but not least, scanner and web scrape data are no panacea, but are a nice area for research, I can tell you. This brings me to the end of the third part and of my webinar. So what we discussed in the third part is the processing of scanner and web scrape data, how we go about classification. Well, technically, I just touched upon that because machine learning would have been another webinar. Index calculation, and we discussed some further issues which you should be keeping in mind when you deal with these new data sources. And I'm open for new questions. Maybe I start with the one which still related to digitalization, but would mutatis mutandis also apply to big data. Are the surveys on prices harmonized? No. For a survey, first of all, what you need is a survey frame. And this survey frame might be very different for the same product in different member states or in different products in the same member state. So there is no general recommendation for the survey frame, particularly since, again, you need to respect national particularities. You even need to respect item particularities. So there are some recommendations which are good sources, but there is no general line for how you should go about surveys on prices. Same story here for scanner and web scrape data. If you consider this to be a survey, no general recommendation either, because you have to live with what you get. If you only get weekly data from your data provider, you have to deal with weekly data, which means it's already aggregated. If you do get daily data, you have to deal with the vast amount of data you receive. If you only get monthly data, well, there's little you can do about that either. So you have to live with what you get. Of course, ideally, you would like to have the lowest level possible, but then you have to deal with that level of disaggregation. So general answer, no harmonization of the service, but yes, recommendations on how to process scanner data. So there's actually a guide published by Eurostat on how to process scanner and web scrape data. Follow-up question, can scanner data solve the harmonization issue? Well, maybe. I don't know yet. If I give the next seminar in a couple of years, I might be able to answer that. Certainly, there is a big possibility or a big opportunity. So, opportunity for scanner data to foster harmonization in the isHICPE, because it's a new field. And if just everybody does the same, you immediately have harmonization. Even the data might be some way harmonized. So you have some change are multinational. So you might get the same format, the same kind, the same structure of data for several member states. So this might be a field for harmonization. On the other hand, it might also be a field for disharmonization. So if now member states tend to do their own approaches to scanner data, so deleting observations which shouldn't be deleted, aggregating products which should not be aggregating, using different multilateral approaches than others. So then you would have an issue with disharmonization. But it's too early to tell, because some member states have implemented scanner data in their actual production of the isHICPE. Some are trying to gain experience with scanner data and web scrape data. Others haven't even started yet. So it's too early to tell at this juncture where scanner data will lead us in terms of harmonization. Any more questions? Never know whether it's a good sign or a bad sign if no one asks questions.
No, I have some, but I mean, I just would like to add that I know that in Italy, the National Institute is doing is using scanner data for computing the index. So I'm not sure, but is this information available? Which country already use these sources of data to compute the consumer index?
Well, I'm yes and no. So who certainly does know it is Eurostat, but I'm not aware of a public repository where you can look it up in that level of detail. So there are, I think it's called quality reports, where you can look up the general calculation methods by member state. That's available on the Eurostat website. But it might not be detailed enough to tell you precisely in which areas they're using which particular method, etc.
Okay.
So I'm not sure there is an overview available to this extent. On the other hand, it's not truly confidential information. So there are others which are much more advanced, for example, and where I do know that it is available on the USAID website that they are dealing with price changes using scanner data and web scrape data. Well, we do have an overview of who does what, but I'm not sure that this is publicly available. If someone is interested in that, now addressing the USAID colleagues, a question to you guys whether this can be made publicly available if someone comes up with a follow-up question on that.
Okay, thank you. So if we have no more questions, I think that we can finish with our webinar. So I would like to thank Jens for this very interesting lecture. And I also would like to thank all our participants who joined us today from many different places. So you can already download the presentation used by Jens from the EMOS 2020 events website, where the recording of the webinar will be also available as soon as possible. On the same website, please consider that you can already find the recordings of the first two webinars that we had. In the meantime, I kindly ask you to check the inbox of your email account, the email account that you used for registering to the webinar, as you have already received the link to a short survey about today's webinar. We'd really appreciate your feedback to further improve our webinars. The next webinar is scheduled for next Tuesday, 24th of March, where Mark van der Loo from the CBS will be presenting on R, Python, and Julia. Do you know them all? So a lot of people are saying thank you to you, Jens, in the chat.
I see that. You're welcome.
Okay. So thank you again, and I would like to say bye-bye to everyone. So I hope you be part of also our next webinar. Thank you.
Take care. Bye-bye. All
Bye,
the best
bye,
to you. Bye-bye.
bye.